And here is a new episode of the IoT Show where we talk about Edge AI. And once again, this episode is sponsored by the Edge AI Foundation. We thank very much for that. The foundation is about uniting industry leaders and researchers to drive innovation, solve global challenges, and democratize AI technologies. And one of the ways they're doing that is organizing challenges for professionals to come and try new things. In that case, we had a challenge recently about working on a big data set for vision AI models. Some were looking at it from the perspective of the models, others were looking at it from the perspective of data. And this is exactly what Kais did, one of the winners of these challenges. He looked at the huge data set that was provided and had some very interesting ideas we'll talk about today on the IoT Show. Do not forget to subscribe for the channel, to like the video, and to leave a comment because I'm sure you have questions. Hi everyone, this is the IoT Show. I'm Olivia, your host. Today we talk Edge AI, and for that we have Kais with us, one of the challenge winners of the latest Edge AI Foundation competition or challenge. We'll talk about that. And Kais, how are you?
I'm feeling good.
Good. Do I say your name correctly, by the way?
Indeed, yeah. It's Kais.
Awesome. So tell us about yourself. Who are you? What do you do in life?
Yeah, I'm a computer vision engineer in Belgium. I've been here for 3 years, and I've been working in this field for four, maybe almost five. And I've always been fascinated about it since my university days. And with every experience I get, I'm just like get super. I love diving into it. And also, I'm a big fan of Edge AI as a concept and to bring machine learning and AI application to smaller devices and to really to the data sources. And that's one of why what the main reason of why I participated in this challenge, which we will talk about in a few minutes.
Yeah, definitely.
And yeah, I'm stoked to be here.
Yeah, well, no, thanks for your time and for coming to the show here to share your experience. We do talk a lot more these days about Edge AI. This is the big trend that is supported by IoT technologies, and our audience is mostly IoT practitioners, but they are more and more interested into what's going on with Edge AI. So we'll talk more specifically Vision AI today, I would assume, right? Because that's your background. And I
Yeah.
also I'm curious to know, what is your take on the evolution of Vision AI? Because we talk about IoT supporting Edge AI coming strong in that domain to leverage edge compute capabilities. What is, from your perspective, what has been the evolution of Vision AI in the recent years?
Yeah, from a hardware point of view, I've seen it go from having few companies developing the developer boards just for fun, just for
Mhm.
like students for academic research. But then it has been exploding for the past years. One, computational power now is more available to put it in a very concise device. We see it on our phones, we see it on our laptop GPUs, but we also starting to see it in dedicated hardware like
Mhm.
NVIDIA Jetsons, Raspberry Pis. The one that came out recently is also powerful enough to run object detection, for example. But what we also, I think, what also been happening in the past 4 or 5 years that a lot of industries are starting to see the importance of edge AI, the importance of bringing AI to the edge. We see it from autonomous cars, from my sector where I work, which is autonomous boats in the maritime field, industries, laptop, like phone and communication devices, etc. So I think the industry is starting to see the importance of edge AI, and that's where we're seeing the hardware exploding, open source tools and frameworks exploding, and more people are coming into this.
Yeah.
Even we see people like Hugging Face, which are known for large language models, are now going towards smaller language models or smaller vision models because we know the world is going into this direction.
Nice. Yeah, for many reasons, right? Privacy, security, cost,
Performance, yeah.
efficiency, latency.
And when you talk about, I don't know, some applications in the aeronautics field or autonomous cars, autonomous vehicles in general, you have a highly critical system. You need
Mhm.
fast performance and you need it to act immediately.
Yeah,
So you cannot, let's say, sacrifice to have some data sent to the cloud, wait for processing, and then send it back in.
yeah.
So having your processing locally, and your IoT fans will know, is the key to have this critical performance.
Agreed. So you participated in that challenge that the AGI Foundation put together. So tell me a little bit about this challenge. And you started, hinting about, the reasons that made you want to participate in the challenge. So tell me about the challenge itself and your take on it.
Yeah, it revolves around, let's say, a large data set that was constructed by a group of researchers, I think mainly from Harvard,
Okay.
that's called the Vision Wake Word. And the goal of that data set is it has images of people or images of backgrounds taken from a lot of sources from the internet. So it's very diverse, it has a lot of setups, a lot of scenarios, etc. And the goal is to use it to train models or to benchmark models that are meant to be good at classifying the presence of a person, whether this image is of a person or not. Um, and now the data set that it has, I think, 5 or 6 million images in it. That's what
Wow.
they collected. So it's quite large. It's, like I said, it's quite diverse. And the goal of the challenge, or the organizers of the challenge, they wanted to have two tracks. One, they wanted to have a certain people, or they encouraged people to participate to try to create a new model architecture, a new CNN or transformer or wherever, that will train better on that data set and exceed the current benchmarks. But they also had a data centric, that's called the model centric approach. And then they had the data centric track or data centric approach, which is they encourage participants to act on the data itself, to play around with it, modify it, correct it, do whatever is necessary, and then train one specific model, one specific architecture, and try to optimize that model's performance by
Okay.
just enhancing the data or improving the data quality. And that was the track that I participated in. Why? As much as creating models is quite fascinating and cool, in the real world, and when you work for certain companies, when you're trying to develop, let's say, a real world application, you quickly realize that data is your most valuable source. It's probably 90%, if not more, of the value of what your AI model will bring. And so that's why I focus on the data centric approach. I wanted to, and for me, it's something new because I never worked with a data set this large.
Mhm.
So I wanted to, one, as a challenge for me to try it out, to experience some analysis techniques on a large data set, and also in a new field, which is like detecting people, so different scenarios, etc. But also, my goal was to again prove, even with a competition, that data is the key. Data is the key to
Mhm.
have a very performant model, to improve model performances, and that no matter how large your data set, no matter how many people participated in creating that data set, you will always have flaws, and you will always have, let's say, weakness points in those images that you need to address.
Okay. Interesting. Interesting. That's indeed a perspective that is refreshing because people talk a lot about the models, this one or this one and this open source version, and they don't talk that much about the data and quality of data, which is critical, and someone has to deal with them.
Yeah.
I hear a lot, a differentiation between a data analyst and a machine learning engineer or AI engineer, which at the end of the day, they whether like two people will need to work together or you have to be a little bit of both, right?
Yeah.
Yeah.
Indeed, that's my case most of the time. But I also, as a like as a school of thought, let's say, or as an approach, you need to be biased towards one or the other, right?
Okay.
Depending on your experience, depending it could be also on the use case, you will find yourself fixated on one part more than the other, but most of the time it's the data that's key.
Okay.
And it's not only computer vision application. It could be also in text data or in LLM projects, in IoT related projects like predictive maintenance or whatever. That eventually, if you have good data, you will have a good model. If you have garbage in, you'll have garbage out.
Okay. Yeah, that makes sense. That makes perfect sense. So you were given millions of images. You had them available there. That was your data set. What was your approach to the challenge? What were your, what was your mindset when you first approached that huge data set?
Yeah. So the first thing I had to do was do some data exploration, and for that, I didn't immediately start working with all 5 million images. One, my laptop couldn't handle it, but also it's the idea of like subsampling your data and trying to get an understanding on a small subset, and then you try to scale up your decision making and scale up your approach. So I took around 3% of that data, which was only almost 200,000 images, no more. Um, and then I started, and then I used off the shelf object detection models
Okay.
to analyze that data and get some understanding. And the goal was to try to detect or to look for two possible flaws. One, which images are falsely labeled,
Mhm.
and two, which images that are not labeled at all.
Okay.
Because later on, when training the model, even if you're missing annotations, they could be considered as, let's say, background images, and that will lead for the model to learning false data.
Yeah.
Plus, you might have false annotations in the first place.
Okay.
And
So,
even with
guys,
Go ahead.
so for those who are not super familiar with the process, the idea here you're describing is that you have a set of images. For a model to be trained on, what you have to do is put labels on portion of the image and indicating, hey, this is a person. Like in the case of something that a vision AI model you want to train to recognize people, for example,
Yeah.
you would have to determine a section of the image and say, hey, this is a person. And then another one, this is a person, right? This
Yeah,
is what you call
that's for
label.
the case. That's for the case for object detection, but this
Yeah.
is more a classification problem. So you only had to label the image, the entire
Okay.
image, with a label, whether
Okay.
it's
Got
a
it.
person or not.
Okay, that makes sense. Okay, so the label would be, hey, that image has a person on that on it or not, and that allows to the model to then say, hey, this is a little bit of a binary problem here. Okay, so you had images that were you were trying to find images that were wrongfully or falsely labeled,
Yeah.
or ones that were actually not annotated at all, right?
Indeed, indeed.
Okay.
And that was the case. I think nearly 25% of the
Wow.
subset that I worked on was already unlabeled. So that's unused potential of those data sets because they were quite diverse. They were quite unique, let's say, in a sense.
Hmm. Hmm.
But they were unlabeled, meaning they would be a bottleneck for the model, or they would stop the model or hold the model from actually learning quite some good representations. And also, I don't remember the exact number, but there were also quite dozens of thousands of images that were falsely labeled,
Okay.
just in this 3% subset. So normally it would make you assume or it makes you think that in the entirety of the 5 million data set, there are thousands of images that are either falsely labeled or unlabeled at all.
Okay.
They're just out there ruining the model performances, basically.
Interesting, really interesting. And so you said earlier that you tried and used off the shelf, generic models to
Yeah.
fix the data. So tell me a bit more about that. What was exactly that you did to use these models, and which ones actually you looked into?
Yeah. So going through still like 200,000 images are quite immense. It's hard to go through them manually, whether with one person or a team of dozens of engineers. And luckily, in the past years, there has been great breakthroughs in computer vision models, especially. So I used two of kind of the most used or the most famous ones out there, and that are quite reliable. One for object detection is called the YOLO model. Probably
Mhm. Yep.
your audience knows it, which is open source or openly available online that you can use for research purposes. And that one I used to because it's quite good at detecting people. I ran it directly on the entirety of the data set and tagged images or and labeled all the images or made created predictions with this model of where there are people and not, which
Mhm.
later on I will use to compare against the original ground truth and look for mismatches. So that means if for me, I assume if the YOLO model detected a person, but that image was labeled as a background, then it's definitely false. And this approach also later on helps in annotating the unlabeled images. So again, you use a model that's quite certain at detecting people. You have an
Mhm.
image that you don't know the original label of or annotation of, but that model gives you already a head start. And the second model that I used was is called the Clip from OpenAI, the famous OpenAI, the people behind ChatGPT.
Yep.
And that's also a vision model which was quite good at extracting features. It can also do classification. So I used it to classify images into whether it's a person, a vehicle, an animal, or an item. Why? Because during the exploration phase, I noticed that in the original labels, a lot of animals were labeled as person. It could be the presence of eyes, it could be the presence of a face. I don't know what algorithm was used initially, but that mistake was common. So I thought, what if I use this very well trained model distinguish for me between people images, animal images, and all the others. And that way it creates a better understanding because later on you can go through these subsets of where you have animal classifications and try to see if it was originally labeled as a person or not. So whether it was correctly labeled or not. Similarly, if you have a vehicle image or an item image, so you try to compare the model predictions that I used versus the ground truth data, and then look for mismatches, and then look for and correct those annotations if needed.
Yep.
And in the second stage, or in completing the annotations of the empty images, I basically use, let's say, I consider my models are certain when they have matching predictions. So if the YOLO model and the CLIP model detected a person, that image is definitely a person. Automatically label it, and vice versa. If both of them don't detect a person, then I immediately and automatically assume that image is a background image, and that way, in a matter of minutes, you end up correctly labeling hundreds of thousands of images, and without having to actually look at them.
Interesting.
You end just as the engineer, you're just validating those results
Yep.
or reviewing those results.
So that begs a question, guys, here that just like came up as you were talking. So you were using these off-the-shelf models to determine, to make determinations, inference on these images. And we're talking about edge AI. these models, YOLO, sorry, and Clip, are they big? The things that you just can't take as is and run at the edge? Is it the reason why we're trying to optimize these models to run them at the edge?
No, the edge component comes actually, I mentioned it at the beginning that the goal of the challenge was to use that data set to train
Yep.
a fixed architecture model.
Okay.
That model that will be trained is called MCU net.
Hmm.
Uh, and I think it's also issued by a laboratory from Harvard. And it's a very, very lightweight model that is meant to
Okay.
run on small MCUs and
Yeah. Okay.
small processors.
Yeah, and this is why you're trying to clean up this data set to train that very tiny model, because we cannot afford to run a full YOLO or a full clip model on these MCU devices, right?
Indeed, indeed.
No.
Yeah, the clip model is too large for most of the embedded devices that I know, at
Yeah.
least. And for the YOLO model, you need to go to the smallest, let's say the smallest version, and still you need to run it on a quite sophisticated hardware, like an
Interesting.
NVIDIA
Yeah, interesting.
Jetson or something with a GPU on board. However, this MCU net, it was designed to run on very hardware constrained devices,
Hmm.
and the idea indeed so to train that MC unit. And so if you deduce as much as possible, um, or improve as much as possible the quality of your data set, and you have only the most informative core of it, you train this very lightweight model, then you would have a highly performant model independently of the hardware you need.
Okay. Interesting.
And that's the edge component.
That's the edge component, definitely. Yeah, that makes sense. And that's something that will definitely, sound familiar to our audience here. But yeah, no, it's super interesting. And I wanted to ask you, so you're talking about the fact that better data will give better models, right? So which makes perfect sense, and everything you described definitely helps. Now, in general, what I've seen is people are also trying as much as possible to train their models on real data, as in, they're gonna run, especially if they run that AI model at the edge, they will have specific sensors or cameras, or whatever, specific context, because the device very often is in one place. So you have one type of camera of pictures with one type of lighting and so on. And so is it preferable from your perspective to systematically use generic data sets like the one you've been working on? Or is it preferable to eventually work on smaller data set of real data coming from the actual sensors that you will be running the inference on?
Yeah, it would depend on the use case, because whether we like it or not, even for edge, let's say edge focused models, they are still data intensive. So even if you have your use case, you need to collect a huge amount of data to ensure that you would have a quite good performance. So I would say, unless like you're in a factory and you're doing quality control of a very niche product,
Hmm.
I would say it's best to start with what is available off the shelf online,
Okay.
benchmark it, and then take the decision if you need to improve it, with real world your use case data,
Hmm.
or generic, what you call generic data.
Yeah, that
So
makes
it
sense.
depends on the use case, but that would be my approach if I would take on any project. I would try what is available online. Let's look
Okay.
like for the easiest solution, because then as you're going to start collect data, there's effort in cleaning it, analyzing it, understanding it, annotating it,
Hmm.
to make sure that it will improve your model, or like, let's say, upgrade your model performance.
Interesting.
That would
Yeah,
be kind of the second step.
that makes sense. That makes perfect sense. So going through that challenge and testing your theories of leveraging these generic big large models to clean up the data, what were your big learnings? What are the things that you took away from that experience?
Well, first it was quite fun to do it,
Yeah.
especially like I said, it was a different kind of a different field than what I'm used to. So work on a different type of data, etc. Um, no, but the key takeaway, I think the results I got did prove the theory, or what you call theory, because the organizers of the event did provide a private test set that was
Hmm.
closed out from all the participants towards only after it was revealed after the end of it, that they use to benchmark these models, any model that you would train.
Yeah.
And I noticed a significant jump between using an off-the-shelf MCU net that was trained on I think the entire Vision Wake Work dataset,
Okay.
and then my model, which was trained on this enhanced 3%, and there was a significant jump in the
In
precision
accuracy.
metric that they were calculating on this private test set. So imagine the performance bump we would get once we apply these corrections or this data analysis on a larger portion of the Vision Wakeword data set, and then train a model on that. Then it will reach very high performance results.
So training models on less but better data gives
Indeed.
better results
Yeah.
than a lot of data in general that has errors, and so it's better to go with fewer better data than more okay or bad data.
Or better, it's better to phrase it as start with high quality data,
Okay.
then slowly increase it by keeping control over what you increase. So always monitor your annotations, always monitor, let's say, the semantics of what you're getting. Avoid redundancy, avoid corrupt images, avoid low quality images, so that you are continuously improving your model performance.
That makes perfect sense. Awesome, guys. Great recommendation. Thanks for the insights into the challenge and what you did there. Well, I'm sure the IoT folks listening and watching this will take your advice into account next time they work on some training of some machine learning model for the edge.
Yeah, and I'll be happy for questions. You guys can find me on LinkedIn.
Yeah.
Reach out. I will share with you the project on GitHub, and glad to answer any questions you might have.
Awesome, guys. Thanks very much. See you soon.
Thank you, Olivier.
Yeah, bye.
Bye.